Hello and welcome to the teacher panel discussion for NASA Langley's Earth Right Now Centennial Badge. Thank you so much for joining us. My name is Marile Colon Robles, Marile for short, and I'm an education specialist here at NASA Langley Research Center, and I'm going to be moderating today's discussion. I have with me today three very talented educators to really talk through how to implement the activities, some ideas, and then be able to share some resources for you to be able to implement it in your classroom. So we're going to meet our educators today.
Hi, my name is Marjorie Thrash, and I'm a 6th grade science teacher in Williamsburg, Virginia. I've been teaching for 16 years, and I worked on the badge this summer.
Hi, I'm Jessica Taylor. I'm a NASA scientist here at Langley Research Center in Hampton, Virginia. My background is in meteorology and in education, and I used to teach meteorology at Florida State.
My name is Kevin Hubel. I've been a science teacher for 26 years, and I'm currently an instructional STEM coach for the City of Newport News.
So first of all, we have Marjorie Thrash here, who helped us write the badge. She was a teacher intern here at NASA Langley, and I want to ask you, Marjorie, as a science teacher for so long, what was your experience as you went through the activity?
Well, as I was going through the activity was actually during the development stages, so we really had to think about what challenges the teachers would face, whether it be finding the right materials or having the right type of weather and that sort of thing. So we wanted to make sure that it was affordable and that the directions were clear. So in that, we really tried to think through all the possibilities. So hopefully we tackled everything and that it was easy for the teachers to work through.
How about implementation ideas? So you got really excited about this activity because it's a step up from using clouds, right? Not just cloud types, but its interactions. So can you talk a little bit about that?
It's difficult for children to understand Earth's energy budget. They understand that the energy is coming in and they're not really sure, about the in and out of the energy. And this activity really demonstrates how clouds impact that energy budget, and they can see it and do it, and it makes it very real for them. And so I'm excited as a teacher to actually do this with my students this year. So.
Oh, that's great. So I'll ask Kevin, as you were looking through with the eyes of a STEM coach, what ideas came up and that you would recommend for your teachers on how to implement in the classroom?
Well, you could implement it in many different ways. It's very versatile. You could use it as engaging to a unit, as an introduction to a unit lesson, as a culminating activity, or you could use right in the middle. The videos are extremely informative and lent for a really strong background knowledge for the students to understand, what clouds are all about and what, the energy of cloud is and the budget. And so that's hard to teach out of a textbook. The videos were very entertaining. They're very informative, and then they followed it up with a questionnaire, get the meaning out of the video, not just watch it, but actually watch it for information, and then be able to do the hands-on activities, and they could actually see what the video was talking about by taking temperature data over every 3 minutes with 3 different variations of 3 different variables. And so it was a wonderful lesson. It really incorporated both the English and the science, and we all know that you can't do science if you're not playing with tools and toys. So, but it also lent itself to a lot of grammatical exercises. They had to read, they had to be able to answer questions completely, and that's important for standardized testing.
Oh, that's great. So I'll ask Jessica a question. How does this activity simulate what happens here in NASA Langley and the researchers that are working here studying the Earth?
Yeah, well, thank you for that question, because NASA Langley has a long history of studying Earth radiation budget, and particularly how clouds impact Earth radiation budget. And what I love about this lesson is that it is taking clouds to that next level. It's beyond doing cloud type observations, and many teachers think about clouds as maybe an elementary, somewhere in the elementary curriculum when they learn about cloud types and when they learn about that clouds are made up of water droplets. But starting to go beyond that and talk about how clouds might impact Earth radiation budget does take it to that next level. And what I like to say is, you know, when teachers tell me that it's just for elementary students, I think, well, think of all the scientists here at NASA Langley who are specifically studying clouds and their impacts. And so some of the ways we do that is through observations. And what we take most of the time is we're taking data using a number of satellites that are orbiting the Earth, collecting measurements about clouds. And we look at those over a long-term record to see their impacts. And so doing ground-based observations can also help us understand, but also fills in some of those gaps that the satellites might miss from space perspective.
So talking about clouds, one of the parts of the activity is to actually take the students and do some cloud observations. And you have worked with the GLOBE program. You were a GLOBE student yourself. Can you give us just a short highlight of what happens with that data as it's collected by students?
Yeah, thank you. So I was a GLOBE student when I was at Florida State. So I was doing the same protocol, is what we call it, the steps and procedures that we all agree to take the scientific measurement so that it can be compared. So my data can be compared to Marjorie's data and likewise, and also can be compared around the world. And so that, I think, is the power of doing it with the GLOBE program, is that it is an international program. More than 100 countries participate in this program. And so when a student collects that data and actually inputs it onto the GLOBE database, it's made available basically to the world. So not just scientists here at NASA, other scientists, but also other students, and that student themselves could do research using that data. And that's what I think is really powerful, is then seeing, you know, through your own eyes, making those observations over time and how clouds change, right? So, you know, some of the challenges in doing this is, what if you go outside and there's no clouds? Well, that's a great observation too, right? No clouds is a measurement of clouds. So being able to be actively involved in those observations and then doing some of the thinking part of it and asking questions about, you know, why could there be a temperature change one way or another?
So that's really interesting, having a no observation, it's still an observation, right? And I know, Marjorie, in your classroom you work a lot with variables, right, and the nature of science. So how do you see this activity going into that and into the standards that you're trying to teach to as well?
Yes, in this particular activity, obviously you have some control variables, and we're using the same tubs, the containers, and the same, you know, cotton balls for the clouds. And so it's really teaching that consistency. When you test, when you set up an experimental design, you need some variables to be held constant. And identifying your independent and dependent variable and being able to graph your data and you know, understand the differences between the different containers and seeing how the different cloud types affects it. So it definitely ties in. You could take it to the next level and do a big lab write-up on this activity very easily.
Oh, that's great. So Kevin, I have a question. You have a variety of teachers and maybe classroom constraints. We suggest different ways of doing this activity, either going outside or also just using lamps. How would you guide a teacher on still doing it even if it's raining, or maybe you have a limited number of lamps, let's say?
Well, you could work in groups or even create stations, and the lamps work very well. I mean, what you're looking for is absorption of energy and monitor what happens to that energy over time. So the lamps is a great alternative to just going outside. And if I was to suggest a teacher, I would suggest stations. Go from station to station, record your data as you see different variables, and the students share their results, you know, with each other. Because in science, I think right now the hardest part is not gathering the results; it's being able to interpret what the results mean and being able to explain what happened.
So sticking with that point, what would be some ways to gather and analyze that data?
Well, once you plot your graphs, once you set up your data table, you might ask the students, okay, what are the differences? You know, what might have created a difference in temperature between A, B, and C? And if they can tell you that, you know, one of them acted as an insulator and one of them didn't have an insulation and energy was released, then, you know, they have a pretty good understanding of, you know, what happened during the lab. If they don't give you answers that might be correct, you know, it's a way of assessment. You know what to touch on and what to reiterate with the student, or have other students maybe explain to that student, because students do learn best from each other, that did know, what the meaning of the lab was, or what the data meant.
That's great.
And what I love about the idea of doing it in cooperative learning groups is also you could assign roles if you needed to. And so you could have a data recorder. You could have someone who is making sure that we're timing the measurement appropriately, can kind of have that materials person. And so if you needed to do that, you could certainly do the assigning of roles as a means to facilitate the cooperative learning.
I want to add to this that you can also get students to think about why you use certain materials. What effect would it have if we use different types of containers in this experiment? And so they can understand the need for controls and how important it is to really measure that dependent variable properly to get the temperature. Mm-hmm.
And that's really good, because we're trying to teach students about the nature of science, mm-hmm. right? And how we're coming up with questions that we don't necessarily have the answers to completely, right? There's no one right answer.
Mm-hmm.
Right.
And the process, and it's really a creative process that has to go through into getting those results and analyzing the data and the different ways that you can look at the data. Tables and graphs and things like that is really important. Mm-hmm. Looking through the activities, we identified a few things that might be problematic in certain classrooms. Can you guys think of any other things that might need to be tweaked? Let's say if a person cannot really take their students outside and do cloud observations, let's say. Jessica, I know you've done this activity a lot. Do you have any suggestions for those teachers that cannot take their students outside?
Yeah, so I would say it might depend on, the level of can't take your student outside. If it's something maybe it's raining that day. If you could adjust it to another day of the week, or you could talk about, what clouds are there right now that are raining? Because there are only two types of raining nimbus clouds. And so you could talk about, okay, so let's think about then that experiment. And what do we think what effect do we think these clouds might have then on the incoming solar radiation and the outgoing Earth radiation? And so that's one thing you can do. You could also look at those videos, because those videos provided a lot of examples of the different cloud types. And then another one is, if you're in a facility that has windows, you could do some observations more frequently during the day. So maybe like take an hour of your day and time it that you're going to do an observation looking outside every 5 minutes. That's not perfect, but that's a good way at least to give you some example of what you think the clouds are, because the clouds are going to be moving a lot. And so building and trees and all of these things are obstacles to viewing a full sky. And so by doing it more frequently, you can get some better idea of what types of clouds I have at this moment in time. Those are just a couple of different examples.
Those are great. Let's talk about even extension ideas, or doing it outside of the classroom. I know, Kevin, you were excited about this activity maybe being as for an after-school program.
Right. Yeah, I would definitely consider it as an after-school program. On Fridays, I used to hold after school. We used to do different science experiments based on scientists' theories and whatnot. The cloud would lend itself wonderfully because of the Globe app. I think that's very, very powerful, because if the students know they're part of something big, that's very meaningful to them. Their neighborhood or their area being part of worldwide, study or research will grasp the students' attention, and that's something you could very easily do after school. And even if teachers, per se, couldn't put an app on a computer or a tablet, they could do it through their computer, and the class could come up with a consensus on what they want to put on the program, on the website.
Mm-hmm. As an extension, we've connected with local meteorologists in my school through Skype, and so that would be a great way for kids to have a question and answer session with a meteorologist. I know NASA does some outreach that way as well, so there are ways that you can build upon the experience.
That'll be great. Mm-hmm. So these are really good ideas. where would you implement it in your curriculum? So Marjorie, thinking the details that are being touched on in the activity, where would you implement it?
My grade level in 6th grade in Virginia has a unit specifically about weather, and the Earth's energy budget, ironically, is one of those areas that we kind of struggled with. So it definitely fits right in there. But at the same time, we're also hoping to integrate throughout the year Standard 6.1, which is basically the introduction to science, the science process skills. So that's woven throughout the year, and this helps us. And in the weather unit in particular, we really had a hard time, developing activities where we could control variables, and so this totally simulates something that we really needed. So it filled that gap for us. We're excited about it.
Oh, that's great. Kevin, do you have any suggestions?
I was going to say the same. I would definitely put under scientific investigation if I were a 6th grade teacher, using manipulatives, using equipment, testing variables, interpreting data. And then later on in the year, when they get into clouds, they have that background knowledge, and you don't have to spend as much time or as much reteaching on that topic.
Oh, that's great.
Yeah, I was going to say nature of science is perfect, particularly classes that are doing any sort of science fair project, or having to do something that takes a student through the whole scientific research process. This would be ideal for. And some classes might even want to do this more in terms of looking at it through more the lens of physics and energy. Right. And being very specific about that. I think that's another good opportunity of where you could insert this into your lesson planning.
Those are all great ideas. Jessica, the teachers that are going to be doing this are going to become Globe certified teachers. So can you give us a little bit of what are the benefits of being a Globe certified teacher?
Yeah, we're really excited to extend this opportunity to everyone. This is the first year that the Globe program has been offering online e-training to become a part of the community. The community has been around for over 20 years now, and it's over in over 100 countries around the world. And so when I say community, I really mean it. So Globe is a community of teachers, students, scientists, and citizen scientists now through the new Globe Observer app. All of us caring about our environment in a way because we're interested in our environment. So we're taking local measurements of our environment, and then through the Globe program, because it's that broader community that is internationally based, you can then understand not just your data on a local scale, but looking at it through a regional and then even a global lens. And then because the Globe program is supported by NASA, it's also supported by NOAA, the National Science Foundation, and the Department of State. You can add some of these extra elements on top of it. Why is the Department of State involved? Well, because it's an international program, and we have to build those relationships with other countries. And then NASA and NOAA can bring some of the other scientific perspectives to the program as well. So that's what they really get while doing it through Globe, is it's a community, and then they can also participate in a lot of the Globe different events. So there's an international virtual science fair, and so anyone who is a Globe teacher, their students could participate in that. And so I think that's another really great opportunity through Globe.
Those are all great. Thank you for that. Do you guys have any other comments, maybe tips for any teachers that are going to be trying to implement this activity in their classroom?
I just wanted to mention the value of Globe. As a teacher, it's difficult to emphasize to children how important their data is that they collect. And here is an application where they can collect data and it's meaningful to people outside of the classroom. And that has value that you can't really measure. And I just think that the kids will really, really enjoy it.
So making that loud and clear in the classroom that there's going to be scientists and maybe other students that will be using your data that you just collected. Okay, great point.
I would say do the badges yourself first. It's really exciting how they progress. It really is. From background to application. It's a really good progression of steps and exercises. I think they should definitely do it by themselves first.
Okay.
And I would offer that I know sometimes people are concerned that they're not quite sure what the cloud type is, and so they're a little nervous about making that observation and particularly about inputting it into the database. And so I would say, GLOBE has a number of different tools. Right in the e-training, there are a few different applets, or I think they're called Zebra Zaps, where you can do cloud matching. So you can practice cloud type with some pictures. You can also practice cloud cover with some pictures. That's a great thing to do across with all of your students, that you can do that. In fact, you could give students a blue sheet of construction paper and a white sheet of construction paper. Have them choose with the white sheet of construction paper how much cloud cover they want in their cloud scene. Have them cut it up, so you could fold up that piece of paper into little pieces, so you can say, well, I want 50% of the sky covered. Have them glue that onto that piece of paper, and then have them kind of quiz all the other students. And you'll see, the more observations you make, the better at it you get. And that's a really important part in doing any of these skills where you're doing science and taking the measurements yourself. And in this, our eyes are our tools, right? And so the more skill we have is because we've been doing that through that practice. So I encourage teachers and the students to not be nervous about that and practice it, but please still input that data, because we've done studies ourselves at NASA comparing ground-based student observations to satellites. And the more data we have, the better we're able to make statistical analysis between the two, but they compare really well. And so people are doing a really good job, and they just aren't as confident yet.
Well, thank you so much for all your input and ideas. We hope that this was very useful for you. This is a great activity where the students can create or collect their own data, and it will be used, just like the panel discussed, by researchers. As you go through the next steps, please let us know what are your comments, what ideas you also come up. We would love to hear from you. Thank you so much. So we want to share with you guys today a great resource that'll help you teach the Earth Right Now digital badge. With us today, we have STEM education specialist Joan Harper Neely. So Joan, can you talk to us about the spotlights?
Students often create their own explanation of how science works, which can be a misconception or a faulty understanding. NASA Spotlights are videos produced by students for students to correct misconceptions. High school digital media students research, learn, and write a script to teach science in an engaging way. These student-produced videos are part of a collection of 5 e-resources for teachers. Under the Engage tab, you find a Cloud Spotlight, which addresses the misconception that a cloud's only purpose is to produce precipitation. Under Explore, Explain, Extend, and Evaluate are activities to help students learn the important role clouds play in our Earth's energy budget.
Thanks for that resource. So you can find more information about this resource and other resources like nasawavelengths.org or climate.nasa.gov at the digital badge.